Okay, so let's start with a couple of examples. So we have this kind of a situation now. Combination of two inclined planes, both of which are smooth surfaces, and a cylindrical body wedged in between them. Okay, so with respect to the horizontal, each of these is at an angle of theta equal to 30 degrees. So this is a cylinder of mass 5 kilograms. Okay. So given that acceleration due to gravity is 10 meters per second square, make the free body diagram of the cylinder and calculate the normal reaction due to each of the surfaces. Okay. So try out this question quickly and tell me the answers. Send me the answers over the message. Yeah, we will discuss doubts later. First, we'll do some revision questions. Yes, Ruksha, your answer is correct. Good. Okay, so people are not getting the correct answer. Don't know why. Very simple case of free body diagram. So you can see that on this block there will be two normal reaction forces acting. Okay, so let's say this normal reaction force and this normal reaction force. Now because the angles are symmetrical, you can probably guess that they'll have the same magnitude. But here I will just label them as N1 and N2. Okay. Now as I told you, always remember that when normal reaction acts with respect to an inclined plane, the direction of normal reaction is such that it always makes the same angle with the vertical as the inclined plane makes with the horizontal. Okay. So when you make the free body diagram, all you have to do is be mindful of that fact. So on this body, the forces acting will be weight downwards, mg acting downwards, and the magnitude of mg is known to you. It's 5 kilograms, so it's 50 newtons. And two normal reactions which are acting like this. This one is the N1 in that diagram, this one is the N2. So each of these will be making the angle theta with the vertical, where theta is given to us as 30 degrees. So now what is the problem in calculating the N1 and N2? It's such an easy problem. Let's try and get it quickly. Theta is known to be 30 degrees. Calculate N1 and N2. N1 will be equal to N2 in magnitude. How much it should be? You have to try to solve it yourself. Every question you cannot rely on me to give you the answers all the time. Yes, Rishi, tell me the answer. How much is that? Kunj has got the correct answer. Only Kunj has got the correct answer so far. And it is so easy, just resolve it now. So suppose N1 equal to N2 has some magnitude x which you want to find out. So resolve the two forces now. So N2 के components क्या हो जाएंगे? X cos theta, x sin theta, और N1 के components क्या हो जाएंगे? X sin theta and x cos theta. and the weight is mg downwards. So these two are anyway cancelling each other, and these two have to balance. So 2x sine theta has to balance mg. So that magnitude x has to be how much? Mg by 2 sine theta. I cannot make it easier than this for you to solve here. It's 50 upon 2 into sine 30. So the magnitude for each one is equal to 50 newtons. This is the easiest type of question you can get in Newton's laws of motion. You're balancing three forces where the angle between two of them is 60 degrees. Oh, sorry, my mistake. This component is cos theta and this component is sine theta. So anyway, so there will be 50 by root 3. So this is cos component, this is sine component. So sine components are cancelling, cos components are adding. So just make a small adjustment here. Okay. So it will become 2x cos theta is balancing mg. So mg by 2 cos theta. So that is 2 times cos 30. So how much does x become? 50 by root 3. Okay. So n1's magnitude is equal to n2's magnitude, which is 50 by root 3 newtons. Or you can approximate it as 50 upon 1.73, but this is fine to leave it. Okay, so this will come out to be some 28 point something. So only one person had the correct answer. No? But then you have to take theta with the x-axis, na beta. Resolving of vectors we have been through so many times. If a vector is like this, suppose this angle is theta, then what is this component? It is a cos theta only, na? Okay. Yes, only one person's answer was correct. That is Ohm. 28.86. Sorry, not 28.06. Anyway, so 50 by root 3. You can leave the answer this way also, or this. Okay, let's move on to the next question. Okay, so these are all massless threads. Okay. So if the tensions in these threads are T1 and T2, given that this angle is 37 degrees, okay, and mg is 200 newtons, the weight of that block is 200 newtons, find T1 and T2. Please calculate this correctly, okay? Very easy question again. Same type of method you have to apply. Balancing of forces. Rishi, T2 is correct, but T1 is not correct. T2 is 250 newtons, that's correct. But T1 should come out to be only 300 newtons. Sorry, not 300, 150. My mistake. Half of 300. So at the point where the three strings are knotted together, at that point, tension T acting downwards equals to weight of the block. So that's 200 newtons. Tension T2 acting along this string is at 37 degrees, or theta equal to 37, like this. So now resolve this T1, this T2 tension. So you will get this component as T2 sine theta. So in this case, this will become 3 by 5 T2. You get this component as T2 cos theta. So 4 by 5 T2. And the other two forces are anyway vertical. I mean, are along the axis. So balancing the forces you can see here will give you that T2 cos theta equals to T, which is the weight of the block. So 4 by 5 T2 is equal to 200. That's your equation 1. So this equation will directly give you that T2 is equal to 250 newtons. And then you have the second equation where the horizontal components have to be balanced. So you have T2 sine theta is balancing T1. So T1 is 3 by 5 T2. So that is 3 by 5 into 250. So T1 is 150 newtons. Okay, so simple question. All of you should get this correctly. Okay, now let's move on to some pulley-based systems. Or before we come to pulley-based systems, let's look at another question involving tension, but involving acceleration also now. Okay, be careful about the angles. Na? The angle was 37 degrees over there, so it was quite clear. Anyway, now this next example, combination of two blocks tied by a massless thread. Okay. Now this is an external force of 50 newtons acting at an angle of 53 degrees with respect to the horizontal. Okay. And this is an angle of, this is a force of 60 newtons. Oh no, sorry. This is a force of 40 newtons, but it's acting at an angle of 30 degrees with respect to the horizontal. Let's make this question easier. Let's make this 37 degrees. So this is acting at an angle of 37 degrees to the horizontal. Okay. And mass of A is equal to 10 kg. Mass of the block B is equal to 20 kg. Yes, this is a smooth surface. So find the acceleration of the blocks, okay, the tension in the thread, okay, and the normal reaction on each block. That is normal reaction on A and normal reaction on B. Just work this out quickly, baby. Okay, let me start by giving you the answer. The acceleration you should be getting should be equal to 1 by 15 meters per second square, or approximately 0.067. Very small amount of acceleration you will get. Okay, the tension in the thread you will get will be, just wait a second, I'll tell you the tension. Yeah, so 31.33 newtons. Okay, and the normal reactions you will get will be 76 newtons for E and 160 newtons for B, assuming G is 10, which you should take. Okay, so just check your answers. Rishi, make sure you've taken the masses correctly. Okay, so anyway, let's look at the full calculation. So see, first thing you do is resolve the forces. So this component of this force, and this component of this force, break it into that. So this is F1 cos 53. So that will come out to be 30 newtons, and this will be F1 sine 53. So that will come out to be 40 newtons. And similarly, break this into two components. So this will be F2 sine 37. So that will be 24 newtons, and this will be F2 cos 37. So that will be 32 newtons. So what is happening is, on this system, this force that you are applying, this is F2 cos 37, that is 32 newtons. Whereas this force that you are applying, that is F1 cos 53, that is only 30 newtons. So which one is dominating? The left hand side one is dominating. It is only 30 newtons. Okay. So that is why the system will have an acceleration towards the left. Okay. So now you make each block's free body diagram properly. So A is free body diagram, and all this is in inertial frame, in the ground frame. So A's free body diagram will have these two components of F2. Okay. Tension, weight and normal reaction. Okay. B's will have tension, components of F1, weight and normal reaction, and same acceleration both of them towards the left. So for A you have the equation F2 cos 37 minus T is equal to mass into acceleration. So this becomes 32 minus T is equal to 10A. This is one equation. Okay. And the vertical equation is F2 sine 37 plus Na minus Mg is 0. So you have 24 plus Na minus 100 is equal to 0. So that's your second equation. Okay. Now similarly for B, the block B, you will have T minus F1 cos 53. Okay. That should be equal to mass into acceleration. So this will give you T minus 30 is equal to 20 E. So that's equation 3. Okay. And vertical equation F1 sine 53 plus NB minus weight is equal to 0. So this will give you that 40 plus NB minus 200 is equal to 0. So that's your fourth equation. Now what we do is solve equation 1 and 3. So 32 minus T is equal to 10A. That's your equation 1. And the equivalent equation here is T minus 30 is 20A. That's your equation 3. Add these two equations, you will get acceleration equal to 1 by 15, or 0.0067, sorry, 0.067 meters per second square. Okay. Then substitute that in either of these equations. So you'll get the value of tension as 31.333 newtons. Okay, and then solve equation 2 to get your normal reaction for this one as 76 newtons, and solve equation 4 to get normal reaction for this one as 160 newtons. Okay. So nothing difficult in this type of question. It is just about being a bit patient and solving the free body diagram very carefully and writing the equations for the given free body diagram. Of course, you have to be accurate with your vector resolution. That's the only thing. Be careful about the resolution of vectors, the sine component, the cos component, all that. This time the angle was given with respect to the horizontal. So the horizontal component was cos component and the vertical component was sine component. Okay. So this is the thing you have to practice now, sir. Making the FBTs correctly. Okay. You have to practice this thing, which is why I'm giving you some revision questions to do today. Okay, so make sure each and every step is clear over here, and please message me or let me know in case something. If you have a doubt in any of the steps, I'll explain again. Okay, Rishi. So that's the thing. Be careful next time. Okay. So hope this question is clear. Finish writing this down, people. Okay. Now let's move on next to a situation with an inclined plane. Okay. And from that, let's also move on to something which has a pulley system. Okay, so we have two blocks A and B of identical mass m each, and this is all smooth. Okay. Now this surface is at an angle of 30 degrees with respect to the horizontal. Okay. And now what we are also doing is, from this side we are applying some force on the blocks so that they accelerate like this. Yeah. So given that mass of each block is 10 kg and g is equal to 10 meters per second square, if the system has acceleration of 2 meters per second square as shown, okay, then find the external force F that we are applying. How much is that force? Okay, so there's a horizontal external force we are applying. Then the tension in the thread, okay, and also the normal reaction on block A. On the block A, how much is the normal reaction happening? Okay, so try this out again. So this time, make sure you take all the directions, angles, and components all correctly in your free body diagrams. Okay, there's only one way to learn this without making mistakes, which is practice again and again. So the more number of questions you will practice, and the more you will learn from your mistakes, the better it will be for you. Okay, so let's check out the value. So now I'll directly make the free body diagram here only. So if I take the weight in components, you can see this will be mg cos theta. So that is root 3 by 2 mg, and this component of weight on this side will be mg sin theta. So that will become mg by 2. Okay. And of course, normal reaction will be acting like this. Okay. Here it's very simple. Normal reaction and weight cancel each other. So for the block A, I will have the equation along the inclined plane T minus mg sin theta is equal to ma. Okay. And for the block B, along the inclined plane, sorry, along the horizontal surface, I'll have F minus T is equal to ma. Okay. So now just add these two equations. So T cancels out. This is equal to this. So F will become 2ma plus mg sin theta. So F will become 2 into 10 into 2 plus 100 into half, because theta is 30 degrees. Theta is 30 degrees. So how much is that becoming now? Yes. So those of you who got 90 newtons, your answer is correct. F is equal to 90 newtons. So Ruksar, your answer was correct. Rishi, your answer is correct. Okay. Now once you got this, rest of the things are easy. You can already see from second equation, your tension is going to become F minus ma. So that is 90 minus 10 into 2. So tension is 70 newtons. So that is a tension, right? And normal reaction on A, you can see, is a very easy thing. Normal reaction on the block A will balance mg cos theta. So it will be 50 root 3 newtons. Just write this as n. Okay, let's move on to the next question. Now I'm moving on to a question in H.C. Verma. Okay. We'll do some of the H.C. Verma questions. So when you go through the exercise later, you can see. So I'll use numerical values which are different from the book, but the question is exactly the same. So this is a massless pulley, and mass of A is 2 kilograms, mass of B is 5 kilograms, G is equal to 10 meters per second square. Find the accelerations of A and B. Okay, and the tension in the thread. Okay, Om, I'll take you back to that question, but first try out this question next. Okay. After we finish this one, I'll take you back to the solution of that one once. Okay, so let's calculate the values. So first thing you can see here is that if this has a downward acceleration of E, then this will have a horizontal acceleration of how much? 2A, because if B displaces down by X, okay, what happens? It pulls 2X thread length. The amount of thread length it pulls is becoming 2X. Okay, so therefore A will slide by 2x. So the ratio of displacements is 2:1. So the ratio of acceleration will also become 2:1. So this is called the constraint relation. Okay. Next thing is uniform tension everywhere. Okay. So for the block A, you can see that only one horizontal force tension is giving it an horizontal acceleration of 2a. Okay. Rest of the forces are balancing the vertical force and normal reaction. Okay. Whereas for B, what is happening is that the upward tension is 2t, because there are sum of two tensions, and it's having a downward acceleration of E. So now we'll set up the equations from the free body diagrams. Okay. So for B, we have the equation weight minus 2t is equal to mass into acceleration. So weight is 50 minus 2t is mass into acceleration. This is our equation 1. For A, we'll have the equation that T is equal to mass into acceleration. So T will become mass is 2 kg, but its acceleration is 2a. Okay, so that's the second equation. So T is equal to 4a. So we'll substitute T equal to 4a here. So we'll get 50 minus 8a is equal to 5a. So A, as you can see, will come out to be 50 by 13. Okay. So once we get that, we know that acceleration of A will be 100 by 13 horizontally like this, and acceleration of B will be 50 by 13 downwards like this. So some of you have solved this numerically and further got the answers in approximate form. I'll just verify that for you. Yes, you got it correct. Oh. Okay. And yeah, from this now you can find out the tension. So you can see that the tension is nothing but 4a. So it's 200 by 13, or approximately 15.38 newtons. Okay, let's look at another question basically from HCV, but I will give it some numerical values here for solving. So we have a triangular wedge like this. Yeah, sorry, just a minute. The wedge is placed with this kind of orientation, connected by a thread going around a pulley like this now, with another block connected here. Now there is a small block over here of mass m, and this is a smooth surface. So given theta is equal to 37 degrees, m1 is equal to 14 kgs, small m is equal to 1 kg. We have to find m2 such that the block small m does not slip on the inclined surface of the wedge m1. Okay. Now this is very similar in concept to a question we have done 2 lectures back when we were discussing about pseudo force. Okay. So try solving this. The hint to you in that is that make the free body diagram of small m in the non-inertial frame of the wedge m1, assuming its acceleration to be a. Okay. And then in that free body diagram, what you do is apply condition for the block small m to be in equilibrium. Okay. In the non-inertial frame, it should be in equilibrium to find that acceleration e. Okay. And then use a, and then from there use the value of a to find m2. Okay. So this is a slightly complicated question. Okay. HC Verma has the same question without the numerical values given. You have to just solve in terms of the parametric values of mass. So we'll do this question as a numerical question. Take the value of G as 10 as always. So try this out, people. Okay, so as I was saying in this question, first thing you do is you assume the acceleration is a, and assume that with respect to this is not slipping. So with that assumption, when you make the free body diagram, as I've given you in the hint, okay, make the free body diagram of the small block M in the wedges frame, in the wedge M1, that one's frame. Okay, so that is a non-inertial frame. So that frame is traveling with that acceleration like this. So it's like you are now as an observer, you are standing here, moving along with this. So you see this to be at rest. In your frame, this is at rest because you are moving with this acceleration. So in that frame, when you make the block's free body diagram on the inclined plane, this angle is theta. So there will be pseudo force on the block like this. So pseudo force, remember its direction is always opposite to the direction of the frame's acceleration. Okay, and there will be mg, and there will be normal reaction, and this should be at rest. So you have to balance the forces. Okay. So when you're balancing the forces, remember this angle will be theta and this angle will be theta. So on resolving the forces, after resolving, you'll get pseudo forces component ma cos theta this side and ma sin theta this side. Weights component mg cos theta this side, mg sin theta this side, and normal reaction like this. So when you balance the forces, the condition you will get for this to be at rest is that ma cos theta has to balance mg sin theta. So that means A has to be g tan theta. This becomes the most important thing for us. Okay. Of course, we also get for normal reaction, but that's not so important over here. The important thing is the relation between A and G. So in our particular case, A becomes 10 into tan 37. So that is 10 into 3 by 4. So the acceleration we require is 7.5 meters per second square. So this is the first step in solving the problem. Make sure you understand this. Then we will use the value of acceleration to calculate the mass of the other block M2. Okay, now let me verify the value. Now next thing, what you do is make a combined free body diagram for the block small m plus the wedge M1. Now, because they are moving together as one single object with that horizontal acceleration A. So if you think of this combined free body diagram, because they are moving like one object, there is no slipping between them. Okay. So this is M plus M1 is the mass of that object, और उसपे सिर्फ tension act कर रहा है, giving it an acceleration A, which you already calculated 7.5 meters per second square. The other forces are vertical. Okay. So your equation will become T is equal to M plus M1 E. So the tension in the string you will know is equal to the mass of this was 1 kg, the mass of this was 14 kg, and the acceleration we just saw is 7.5. So the tension is 15 into 7.5. So the tension will come out to be 15 square, that is 225 divided by 2. So that is 112.5 newtons. This will be the tension. Okay. Now next on the other side of the string, here there is this block of unknown mass M2. Now उस पे क्या हो रहा है? There is tension acting upwards, okay, weight acting downwards, and it's having the same acceleration downwards. Okay. So now we know that for this one, M2G minus T is equal to M2E. So from this we will get the value of mass. M2 into G minus A should be equal to T. So the mass of this object should be this tension divided by G minus A. So this tension is, I can now just write this as 15 into 7.5 only. It's easier to work it out this way. And write this as 10 minus 7.5. So see that M2 will become 15 into 7.5 divided by 2.5. So that's 3. So the mass of this block should become 45 kg. Okay. So this is the final solving for that unknown mass. So as I told you, this is one of the more complicated type of questions. Yes, Ruksa, your answer was correct. Good. So this is one of the last few questions in HC Verma. I think question 33 or 34, something like that. So if you just revise through the questions we've done in class today, and once again try whatever questions you are having difficulties with in HC Verma, you should be able to solve most of them yourself. However, any doubts remaining, we will discuss that in the next lecture. And after completing the doubts of HC Verma, we will move on to the next chapter, friction. So that's it for today's session, people. Wish you all the best.